Cosmos is just another word for universe, and cosmology is the study of the origin, evolution and fate of the universe. Some of the best minds in history, both philosophers and scientists, have applied themselves to an understanding of just what the universe is, and where it came from, suggesting in the process a bewildering variety of theories and ideas, from the cosmic egg, to the Big Bang, and beyond. Here are some of the main ones, in approximate chronological order. The Brahmanda, a cosmic egg universe. The Hindu Rig Veda, written in India around the 15th and 12th century BC, describes a cyclical or oscillating universe in which a cosmic egg, or Brahmanda, containing the whole universe, including the sun, moon, planets and all of space, expands out of a single concentrated point called a bindu, before subsequently collapsing again. The universe cycles infinitely between expansion and total collapse. The Anaxagorean universe. The 5th century BC Greek philosopher Anaxagoras believed that, the original state of the cosmos, was a primordial mixture of all its ingredients, which existed in infinitesimally small fragments of themselves. This mixture was not entirely uniform, and some ingredients were present in higher concentrations than others, as well as varying from place to place. At some point in time, this mixture was set in motion, by the action of new mind, and the whirling motion shifted, and separated out the ingredients, ultimately producing the cosmos, of separate material objects, all with different properties, that we see today. The atomist universe. Later in the 5th century BC, the Greek philosophers Leucippus and Democritus founded the school of atomism, which held that the universe was composed of very small, indivisible and indestructible building blocks, known as atoms, from the Greek atomos, meaning uncuttable. All of reality, and all the objects in the universe, are composed of different arrangements of these eternal atoms, and an infinite void, in which they form different combinations, and shapes. The Aristotelian universe. The Greek philosopher Aristotle, in the 4th century BC, established a geocentric universe in which the fixed, spherical Earth is at the center, surrounded by concentric celestial spheres of planets, and stars. Although he believed the universe to be finite in size, he stressed that it exists unchanged, and static throughout eternity. Aristotle definitively established, the 4 classical elements of fire, air, earth and water, which were acted on by 2 forces, gravity, the tendency of earth, and water to sink, and levity, the tendency of air, and fire to rise. He later added a 5th element, ether, to describe the void, that fills the universe above the terrestrial sphere. The Stoic universe. The Stoic philosophers of ancient Greece, 3rd century BC and after, believed in a kind of island universe, in which a finite cosmos is surrounded by an infinite void, not dissimilar in principle to a galaxy. They held that the cosmos is in a constant state of flux, and pulsates in size, and periodically passes through upheavals, and conflagrations. In the Stoic view, the universe is like a giant living body, with its leading part being the stars and the sun, but in which all parts are interconnected, so that what happens in one place affects what happens elsewhere. They also held a cyclical view of history, in which the world was once pure fire, and would become fire again, an idea borrowed from Heraclitus. The heliocentric universe. The 3rd century BC Greek astronomer, and mathematician Aristarchus, of Samos was the first to present an explicit argument for a heliocentric model of the solar system, placing the Sun, not the Earth, at the center of the known universe. He described the Earth as rotating daily on its axis, and revolving annually about the Sun in a circular orbit, along with a sphere of fixed stars. His ideas were generally rejected in favor of the geocentric theories of Aristotle and Ptolemy until they were successfully revived nearly 1800 years later by Copernicus. However, there were exceptions. Seleucus of Seleucia, who lived about a century after Aristarchus, supported his theories, and used the tides to explain heliocentricity, and the influence of the Moon. The Indian astronomer and mathematician Aryabhata described elliptical orbits around the Sun at the end of the 5th century AD, as did the Muslim astronomer Jafar ibn Muhammad Abu Mashar al-Baqai in the 9th century. The Ptolemaic universe. The 2nd century AD Roman-Egyptian mathematician and astronomer Ptolemy, Claudius Ptolemaeus, described a geocentric model largely based on Aristotelian ideas, in which the planets and the rest of the universe orbit about a stationary Earth, in circular epicycles. In terms of longevity, it was perhaps the most successful cosmological model of all time. Modifications to the basic Ptolemaic system were suggested by the Islamic miracle school in the 13th, 14th and 15th centuries, including the first accurate lunar model by Ibn al-Shatir, and the rejection of a stationary Earth in favor of a rotating Earth by Ali-Khshoggi. The Abrahamic universe. Several medieval Christian, Muslim and Jewish scholars put forward the idea of a universe, which was finite in time. In the 6th century AD, the Christian philosopher John Philoponus of Alexandria argued against the ancient Greek notion of an infinite past, and was perhaps the first commentator to argue that the universe is finite in time, and therefore had a beginning. Early Muslim theologians such as Al-Kindi, 9th century, and Al-Ghazali, 11th century, offered logical arguments supporting a finite universe, as did the 10th century Jewish philosopher Saadia Jan. The partially heliocentric universe. In the 15th and early 16th century, Somyaji Nilakantha of the Kerala School of Astronomy and Mathematics in southern India developed a computational system for a partially heliocentric planetary model, in which Mercury, Venus, Mars, Jupiter and Saturn orbited the Sun, which in turn orbited the Earth. This was very similar to the Tychonic system proposed by the Danish nobleman Tycho Brahe later in the 16th century, as a kind of hybrid of the Ptolemaic and Copernican models. The Copernican universe. In 1543, the Polish astronomer and polymath Nicolaus Copernicus adapted the geocentric America model of Ibn al-Shatir to meet the requirements of the ancient heliocentric universe of Aristarchus. His publication of a scientific theory of heliocentrism, demonstrating that the motions of celestial objects can be explained without putting the Earth at rest in the center of the universe, stimulated further scientific investigations, and became a landmark in the history of modern science, sometimes known as the Copernican Revolution. His Copernican principle, that the Earth is not in a central, specially favored position, and its implication that celestial bodies obey physical laws identical to those on Earth, first established cosmology as a science, rather than a branch of metaphysics. In 1576, the English astronomer Thomas Dix popularized Copernicus' ideas, and also extended them by positing the existence of a multitude of stars extending to infinity, rather than just Copernicus' narrow band of fixed stars. The Italian philosopher Giordano Bruno took the Copernican principle a stage further in 1584 by suggesting that, even the solar system is not the center of the universe, but rather a relatively insignificant star system, among an infinite multitude of others. In 1605, Johannes Kepler made further refinements by finally abandoning the classical assumption of circular orbits in favor of elliptical orbits, which could explain the strange apparent movements of the planets. Galileo's controversial support of Copernicus' heliocentric model, in the early 17th century was denounced by the Inquisition but nevertheless helped to popularize the idea. The Cartesian vortex universe. In the mid-17th century, the French philosopher René Descartes outlined a model of the universe, with many of the characteristics of Newton's later static, infinite universe. But, according to Descartes, the vacuum of space was not empty at all, but was filled with matter, that swirled around in large and small vortices. His model involved a system of huge swirling whirlpools of ethereal or fine matter, producing what would later be called gravitational effects. the static, or Newtonian, universe. In 1687, Sir Isaac Newton published his Principia, which described, among other things, a static, steady-state, infinite universe, which even Einstein, in the early 20th century, took as a given, at least until events proved otherwise. In Newton's universe, matter on the large scale is uniformly distributed, and the universe is gravitationally balanced but essentially unstable. The hierarchical universe, and the nebular hypothesis. Although still generally based on a Newtonian static universe, the matter in a hierarchical universe is clustered on ever larger scales of hierarchy, and is endlessly being recycled. It was first proposed in 1734 by the Swedish scientist and philosopher Emanuel Swedenborg, and developed further, independently, by Thomas Wright, 1750, Immanuel Kant, 1755, and Johann Heinrich Lambert, 1761, and a similar model was proposed in 1796, by the Frenchman Pierre-Simon Laplace. The Einsteinian universe. The model of the universe assumed by Albert Einstein, in his groundbreaking theory of gravity, in the early 20th century was not dissimilar to Newton's, in that it was a static, dynamically stable universe which was neither expanding or contracting. However, he had to add in a cosmological constant to his general relativity equations to counteract the dynamical effects of gravity, which would otherwise have caused the universe to collapse in on itself, although he later abandoned that part of his theory, when Edwin Hubble definitively showed in 1929 that the universe was not in fact static. The Big Bang model of the universe. After Hubble's demonstration of the continuously expanding universe in 1929, and especially after the discovery of cosmic microwave background radiation, by Arno Penzias and Robert Wilson in 1965, some version of the Big Bang theory has generally been the mainstream scientific view. The theory describes the universe as originating in an infinitely tiny, infinitely dense point, or singularity, between 13 and 14 billion years ago, from where it has been expanding ever since. The essential statement of the theory is usually attributed to the Belgian Roman Catholic priest and physicist Georges Lemaitre in 1927, even before Hubble's corroborating evidence, although a similar theory had been proposed, although not pursued, 1922 by the Russian Alexander Friedmann in 1922. Friedmann actually developed two models of an expanding universe, based on Einstein's general relativity equations, one with positive curvature, or spherical space, and one with negative curvature, or hyperbolic space. The oscillating universe. This was Einstein's favored model after he rejected his own original model in the 1930s. The oscillating universe followed from Alexander Friedmann's model of an expanding universe based on the general relativity equations for a universe, with positive curvature, spherical space, which results in the universe expanding, for a time, and then contracting due to the pull of its gravity, in a perpetual cycle of Big Bang followed by Big Crunch. Time is thus endless, and beginningless, and the beginning of time paradox is avoided. The steady-state universe. This non-standard cosmology, that is opposed to the standard Big Bang model, has occurred in various versions, since the Big Bang theory was generally adopted by the scientific community. A popular variant of the steady-state universe was proposed in 1948 by the English astronomer Fred Hoyle, and the Austrians Thomas Gold and Hermann Bondi. It predicted a universe that expanded but did not change its density, with matter being inserted into the universe as it expanded in order to maintain a constant density. Despite its drawbacks, this was quite a popular idea until the discovery of the cosmic microwave background radiation, in 1965, which supported the Big Bang model. The inflationary or inflating universe. In 1980, the American physicist Alan Guth proposed a model of the universe based on the Big Bang, but incorporating a short, early period of exponential cosmic inflation in order to solve the horizon and flatness problems of the standard Big Bang model. Another variation of the inflationary universe is the cyclic model developed by Paul Steinhardt and Neil Strauch in 2002 using state-of-the-art M theory, superstring theory, and brain cosmology, which involves an inflationary universe expanding and contracting in cycles. The multiverse. The Russian-American physicist Andrei Lind developed the inflationary universe idea, further in 1983 with his chaotic inflation theory, or eternal inflation, which sees our universe as just one of many bubbles that grew as part of a multiverse owing to a vacuum that had not decayed to its ground state. The American physicists Hugh Everett III and Bryce DeWitt had initially developed and popularized their many-worlds formulation of the multiverse in the 1960s and 1970s. Alternative versions have also been developed where our observable universe is just one tiny organized part of an infinitely big cosmos, which is largely in a state of chaos, or where our organized universe is just one temporary episode in an infinite sequence of largely chaotic and unorganized arrangements. If like the video, then don't forget to like and subscribe the channel. Thanks for watching.